Hi, today I'm going to try and fit a water level sensor onto the coolant expansion tank of this MG ZS, same as a Rover 45. The issue with this car is the tank is very shallow, so you can't use this sort of level sensor because there's just no room for it to fit in place. The only sensor I think is going to be suitable is this sort, which is fitted from above, and I believe the height of it should be adjustable, and the only place that a level sensor could really be fitted is in that sort of position, going down inside this first quadrant of the tank, because you can't get through to the other quadrants because of the internal dividing sections, and we're going to have to feed it through the cap of the tank, or through the hole in the tank, and it's just about short enough so that we can feed it through in this sort of position, drop it down. We'll come to that in a minute. So first of all, get your sensor. I'll put some links in the video description. Check it does operate correctly before you put it on with a multimeter. Put it on to either resistance or diode test scale. This one beeps on the diode test position. We should be able to hear it beeping. Yep. There we go. As the level drops, it beeps. Make sure that works reliably. And the first thing we really need to do is remove the tank so we can drain the fluid and wash out any plastic bits that get created when we drill the hole through the top of the tank. So it's just a couple of bolts, I think, here. Undo the pipes, try to minimise the leakage of fluid, and then we'll look at drilling the hole. I'll also just mention how we're going to indicate to the driver that the water level has dropped. This was a little circuit I knocked up last time on my other video. Put a link up on the top of the video here to link to that one. That was all about putting a water level sensor on a Freelander 1. One option was to use this circuit to filter out or slow down the signal that comes from the level sensor, so that it has to give a consistent reading for 8 or 9 seconds before a beeper would go off. And that's because the previous level sensor was susceptible to moving up and down with water sloshing around. This is probably less susceptible, but we'll see whether we need that circuit or not. And to be really, or to have a really simple indication, you could just get an LED light such as this, or you could just use a simple beeper. This set of LEDs has the resistor in series with the LED, which is essential if you're going to run it off 12 volts. It's actually just in there. So you can connect this directly to your car battery supply, 12 volts. Comes on with a reasonably bright blue light in this case. So all you've got to do is have that connected to your level sensor, connect up to a power source that's connected to the ignition supply, 12 volts, and you've got a very simple level detector. So lots of different options: straightforward beeper with a circuit, an LED light, or I think in my last video I mentioned using a BBC microbit to actually give a verbal warning, speaking out when the water level was low. So let's get on with drilling that hole. Remove the pipe, and then remove the pipe from underneath. This is actually a 6mm socket on my wrench, or we could use a screwdriver. Undo the Jubilee clip. You might have a different clip on your car. And then we need to keep the pipe high up, so we'll just push it over there like so. Empty the tank into a coolant bottle of antifreeze. And now, because the level switch only comes with a couple of nuts, I found a couple of more washers. These are rubber washers, and I think that's a copper sump plug, stainless steel washer that we can use to make a better seal. So have a look on eBay or whatever for getting a couple of suitable sized washers. Then we'll set up our first set of washers and the nut approximately like that. So you need to line it up next to where you think is going to go in the tank. which I believe is something along those sort of lines, about that sort of position. So the nut is roughly the right sort of height, be adjusted later. We need to put some thread sealant around the thread to stop the water coming up actually around the thread and out of the tank. So you could use gasket sealant. So any of these gasket sealants would probably do. Got red, blue. This is a flange sealant, Loctite 574, probably would do. The one that's actually suitable for thread sealing and the presence of water is Loctite 572, so I might use that. You need something like a 10mm drill bit to drill the hole. Alright, so the only way this is going to fit in the tank is going to be to put it in upside down. Put it in that way first. Keep hold of the wires. And push that down. That will actually go all the way in. We lay it horizontally along the bottom. We're going to have to poke these wires up through the hole, and hopefully we can push it out through the hole, and it'll be in that sort of position, which means we need the hole a little bit diagonal. You see, we can't put it in like that because there's not enough room to get it in. So, but if we approach it from the other way, we should be able to pull it up through that hole. A little bit of an angle on it, just make it easier to get that thread through. So with a 10mm hole, that is fine from the top. Try and knock off any burr from inside the tank, inside the hole. Similarly on the top, probably use a knife or scalpel to do that. We put it in upside down, like so, just about pushes around the corner. And you can see it's sitting in the tank. Use the wires to help us pull it up through the hole. There we go. And hopefully can try and persuade this. So it was quite a good guess with that nut position, because that's in now very nice and tightly, near enough vertical. Float still moves okay. Some more sealant on the rubber washer, followed by stainless steel washer, followed by the nut. So 16mm spanner will do. I'm going to do it tight enough so it's a good seal. Don't over tighten it so that it forces the rubber washer to splay out too much. In fact, I'm going to back it off a little bit, because there you can see the rubber washer is starting to splay out a bit, which you don't want. So I'm going to slacken it off, push that rubber washer back in again. And this is the trouble actually with putting sealant around rubber washers, that of course it lubricates them, makes it easier for them to splay out. Good enough. Obviously we're going to have to check for leaks once it's up and running, and you might even want to try it without sealant, or maybe just sealant on the actual thread part itself rather than actually on the rubber washer. That would stop it sliding around too much. So that is it fitted and back in place. The height that this sensor sits is a little bit marginal and just starts to touch on where the bonnet shuts. So what I'm going to do is get a Dremel, try and cut all the way around the nut rather than the stud, and try and remove that while still leaving the wires in place, which could be tricky. So that's my cheap little Dremel imitation type grinding disc. And there we go, with the top taken off. And unfortunately the sealing plug is only in the top part of this threaded bolt, and now I can actually lift the whole of the sensor out. So this is probably a reed switch covered with a bit of insulation. So it's about, this is the end of it, it's about 16mm that has dropped off, and that would be easier if you clamped it on a bench and used the disc cutter to go around and chop the end off. And there's the two wires connected with a bit of shrink wrap insulation put on, cable tied around the top to bend it over, clamp it to the top with a bit of polymer sealant to waterproof it. The cable tie and bending it down then stops it rubbing against the bonnet. So all we've got to do now is connect one of these wires to the convenient local earth, clamp the wire underneath after stripping off the insulation. So next we need to get the wire into the cabin. So I had to undo the bolt holding the tank again, just lifted it out of the way, and you can see here there's a main wire, a bit of wiring loom that goes through into the bodywork. So you can use a coat hanger taped onto the wire you want to feed through, push that past the rubber into the cabin. Inside the cabin, take off this little glove box money holder, 3 Phillips screws, one there, one up here, one on the other side, then this cover over the fuse box comes off. There's the fuse box, and then this is the list of what fuses does what. It's not something that comes on when just the ignition switch is on. So I think we'll go for the ABS system again, which is fuse number 16. This fuse, I'm just about pointing my finger there. So we pull that out and work out which side is the fused side and which side is the supply side. Quite stiff. And then we need to get a multimeter, turn on the ignition and find out which side is at 12 volts with the ignition on, which side is at 0. And we push our wire in to where it's 0 volts, and then when the fuse is back in, then it'll be at 12 volts. And the fuse will protect any issues with the wiring. Right, so here's the LED light bulb that I've just temporarily squeezed in by the dashboard. Wire down here, round into the fuse box. The red positive wire for the LED is now squeezed into the bottom part of this fuse here. So it's protected by that 10-amp fuse. Just make sure it's nicely squeezed in between the blade of the fuse and the hole. Obviously remove the insulation from the wire, give it a tug, make sure it's nice and firmly positioned. Then the black wire of the LED goes onto the wire that goes off to your level sensor. Then that grey wire attaches to the red wire of your level sensor. Tuck those wires out of the way in a minute. We can test the operation just by pushing down on the float and looking at the LED. So there's the LED shown for the windscreen. Push down on the float and you see the LED coming on as I push down. About a centimetre or so before the light comes on. That might be good enough, but we might need to put on that filtering circuit to stop it giving false alarms if you don't want that light flashing all the time. That's with it refitted, the wires tucked nicely out of the way, bolts back in. We'll go for a test drive and see how well that works. Okay, so I've been for a test drive. These are the little lights that shows up the level, and probably as partially expected, what you find is the light comes on when you're turning a long right hand bend, which means the water in the tank is then swilling to the left hand end of the tank away from the level sensor, and of course the light comes on because the level has then dropped. And actually the same thing when you're accelerating, especially when you're accelerating uphill. For all of the time you're accelerating, the water is rushing towards the back of the tank, and again the front of the tank where the level sensor is, the level drops down, sensor activates and the light comes on. So certainly what we want to do to make it less annoying is try and filter out that signal, or slow down the signal, so that it only really activates when the level has dropped for, ideally I would suggest probably about 20-30 seconds, because if you're on a long right hand bend or when you're a long uphill, then you really need quite a long time constant for that filter. So what might be better is to use the BBC microbit to program in a long time delay. Possibly we could do it with an electronic circuit that we showed earlier and on the previous video for fitting it to a Freelander 1. So that's the next step, I think. I mean, you could leave it like it is. The light is not too annoying in the daylight, but I suspect at night time that quite bright light is going to be a bit annoying, and if you had a beeper of course then that would be more annoying. So here's a little electronic circuit that will slow down or filter out the signal from the level sensor. This little circuit, this particular one's got a beeper on it. This beeper doesn't make any sound until this level switch is activated for about 8 or 9 seconds continuously. So it does tend to filter out any sloshing around. Could really do with a bigger time constant. So increase the time that it filters for. We need to increase the value of this capacitor. Look through my spares box and I had some 4,700 microfarad capacitors. So I think I'll put a couple of those. There's 2 of them here. These came from an old PC power supply, I think. You can similarly order them on eBay or electronics parts supply, Maplins and so on. And because in this particular setup at the moment we're using an LED, instead of the beeper, then we cross that out. I'm going to use an LED which has a symbol of this. That's the symbol for it. And so basically this is the negative side or cathode of the LED, so it conducts when this is negative. That will then connect over where the beeper used to connect. So the LEDs, as you saw earlier, there's a set that are quite convenient to buy. This is a blue one. It actually comes with a resistor in series with it, which is hidden under this insulation. So for this circuit we actually need to cut out or short circuit that resistor to connect directly to the LED, because part of the way the circuit works is in order to stop the light coming on too soon, we have this Xenia diode which only starts conducting when the voltage across it is, in this case, 5.6 volts. So this voltage across the capacitor, which slowly charges up through this resistor, has to reach 5.6 volts plus whatever voltage the LED needs, which is about 2 volts. So let's say this voltage across the capacitor has to get to about 8 volts before you get any current going through the LED and before it starts producing any light. And it takes quite a while for the capacitor to charge up through this resistor. The time is determined by this resistance value times that capacitance value, and roughly that's what you get in seconds. So this is 3.9 k ohms, so 1000 ohms. So this is now, we're going to make this roughly about 10,000 microfarads. So a microfarad is a millionth of a farad. So we've got 10,000 of them. That's like 10 millifarads, which is 10 1,000ths of a farad. So the 1,000ths tends to cancel out with the k, which is 1,000. So the time constant is 3.9 times 10, which should be roughly about 39 seconds before this LED comes on. And to make life a little bit easier, whereas previously we had to specify 16 or 18 volts or so, now because we've got an LED, the voltage across this LED will only go up to about 2 or 3 volts. The voltage across this is 5.6, so this voltage across the capacitor only goes up to about 8 or so volts. And so these capacitors, which are actually specified at 10 volts, will be fine to use for these capacitors, which is handy because then they're a little bit smaller and a little bit cheaper. So don't be too afraid of this circuit. All you need is a soldering iron to solder it all together. The other components, which I got out of my spares box, I had to order some Xenias recently, are quite simple. Little diode, couple of resistors, Xenia diode, all readily available. So you just got to connect them up, solder them together, and it's only got one input, 12 volts, one output which goes to your level switch, and that should hopefully give us about 30 seconds worth of filtering of the signal, which means the light won't come on until you've got a very consistent reading out of your level switch, i.e. it's consistently low for 30 seconds. So it should be better at giving a true indication of when the water has really run out, rather than just as a result of the water sloshing around. I suppose it's still possible if you're going around a very long bend or up a very steep hill accelerating for over 30 seconds, it might occasionally come on, but that should be fairly rare. So let's make up the circuit, connect up, and then I'll go for a test drive again, see how we get on with that. So there's the resistor inside the insulation of the LED, so we just need to desolder that, connect that wire directly to the LED. And there's our circuit with the wire to the LED connected. This red wire also goes off to the ignition connection, and which end is it? This connection here goes off to our level sensing switch. So we'll just test that out on the bench first to make sure that it's behaving as we expect. Here we have the circuit, and we'll start counting when we connect our 12 volt power supply to it. So here goes: 1, 2, 28, 29, 30, 31, 32, 33, and you can see now the light is just starting to come on. So around 30 seconds, which is good enough, I think. That's about what we needed, and now the light's nice and bright. And a momentary disconnection for about a few seconds, turns the light off and won't come back on again for quite a few more seconds. So this circuit actually biases it more to stay off than on, because it's got a 1k discharge it's got a 1k discharge resistor, but a near enough 4k charge resistor. So there's a 4:1 ratio in how quickly it charges compared to discharges of the capacitor, which means it's more likely that the light stays off, which is good, because then you've got to have a fairly long consistent reading from your level switch before the light will actually come on. And that is with the circuit wired in, everything insulated off. Let's just leave that 1 kilo ohm resistor exposed. It does dissipate about 0.2 of a watt, so it just allows it to dissipate that heat, shouldn't be a problem. And then just tuck it out of the way somewhere so that it doesn't pull on the wiring. So after test driving it with that new filtering circuit in place, I have to say it's a lot better. I wouldn't say it never comes on. It starts to come on dimly if you're sat, parked, facing uphill, but it tends to build up very dimly before it gets bright, and hardly ever gets really bright as a false alarm. So it's good enough, certainly a lot better than what it was. So that's how to fit a water alarm to your expansion bottle. Thanks for watching. Hope it helps somebody. And after the end section, there is, and possibly an advert, there is a little section on me describing a little problem I had with the quality of that particular sense that I had and how to fix it. So again, thanks for watching, and bye. Now hopefully you won't be this unlucky, but I'll just mention it. When I wired it all up, my little LED was coming on very dimly when the water level was okay, which means the sensor switch was conducting electricity a little bit. And when I took the reed switch out, it was a bit wet at the end. I know depth of tissue in the end, it was coming out wet at the bottom, which meant a tiny little pinhole in the tube. Bit annoying. Shows perhaps the quality of the sensor, these made in China things. Bit annoying. So hopefully you won't be that unlucky. If you are that unlucky, I'm going to actually fix this one. I put a hot air gun on the reed switch to steam out any water that was in there. Plugged the end of this shrink wrap piece of insulation around the reed switch with a bit of polymer sealant. And then what I'm going to do, after having dried it out with a bit of tissue, I am going to seal it up with a resin-like compound that's very, very liquid to start with, and that is a 2-pack paint. So I'm going to use a clear coat paint with its hardener, mix up a very small amount of solution. That hardens in a few hours and goes to a very hard nylon-like constituency, which should be good to seal up the little pinhole, and also should be able to stand the temperatures in the expansion tank, because after all this is car body paint, and car bonnets in sunshine probably go up to at least, I would imagine, 100 degrees centigrade. So that should provide a good seal and keep the water out. So I mixed up in a little pot, 2 parts clear coat, 1 part hardener, I think is about right. Squeezed it together, poured it in to the level sensor, pops the reed switch thing on top. Just pressing a little screwdriver on there because it's a bit more buoyant than the resin. Just get that little top up as the air bubbles just rise to the top. Oops, a little bit too much. So I'll just leave that set for a few hours and hopefully that'll then set rock hard and seal nicely. Hopefully you won't have that problem, but if you do, that's one way to fix it.